In the first video of this series, we're going to be covering basic data concepts and SQL, which is essentially a gateway to data mastery. I'm your presenter, Gabriel Garcia. In our agenda for the introduction to data and SQL for business insights and career growth, we're going to start off with a brief introduction to this video and the series as a whole, and the purpose of these videos. Then we're going to move on to core data concepts, including data warehousing and databases. It's okay if you've never heard of these before, we're going to cover everything. Then we're going to jump into the different objects and schemas that live within data warehouses and databases, including tables and views. Then we're going to move on to SQL basics, which will include an introduction to SQL syntax, including practical SQL examples. We're also going to include a segment about career growth and market outlook. This is important to know why you're learning SQL, whether that's for a career inside of data or that's just to access data for your own personal use. There's a lot of demand for this skill. Then we're going to talk about different data-related careers and opportunities that lie within the industry. And then lastly, we're going to actually pull a tangible example on LeetCode in order to enhance our skills. As I've mentioned before, my name is Gabriel Garcia, and I'm going to be your guide to mastering data concepts and SQL. Having a role of a manager of data strategy and analytics, I simply put love my job, and I want to encourage others to join inside of the data field as well. Different certifications I have include a PMP or a project management professional, as well as a Microsoft certified solution expert in data management and analytics, which covers SQL. I have an MBA in business intelligence and IT from California State University, San Bernardino, and as I've mentioned, 7 years in the data field. But more on the purpose of these videos. This course, as well as the accompanying courses after this, are designed to demystify the data concepts and SQL that you're going to be learning, for all skill levels. Whether you're just starting out or you're looking to refine your expertise, essentially our goal in this channel is to guide you through that process and help you to learn the different knowledge and skills needed to navigate the data landscape and be confident about it. Before jumping into the technical information I'm covering today, I want to first talk about the purpose of data in the modern world. It's becoming more abundant today that our world is a data-driven world. Understanding the fundamentals of data management and manipulation has never been as vital or important as it is today, thus making it not just an asset, it's a necessity to know SQL. SQL, or structured query language, is the key that unlocks this potential, enabling us to ask difficult or complex questions and derive meaningful insights from the vast oceans of data that are out there. A critical role of data in decision-making and innovation is where SQL lies. Structured query language, the technical definition for data interaction, is a standardized language used to communicate with databases, manage, and manipulate data. Next, I want to touch on understanding the differences and the similarities between data warehouses and databases. Database is an organized collection of structured data. A database stores current transactional data for day-to-day operations. As I've shown here in this image of the bookcase, you can imagine the bookcase being the database, and you can imagine all of the different books on that bookshelf being the different objects that live within a database. Whereas a data warehouse is a central repository for integrated data from multiple sources. A data warehouse consolidates large volumes of historical data for analysis and reporting. A data warehouse can contain multiple different databases filled with multiple different objects within those databases. And so we can think of the hierarchy that you have a data warehouse, you have databases, and then you have objects within. And the key difference between these two is the scope and the complexity of the data management at hand. Now, as I mentioned in the previous slide, schemas and objects live within databases. And I want you to think of a schema as a logical collection of database objects, including tables, views, and relationships among them. Schemas play a critical role in data for decision-making and innovation, especially between different types of data sets that you have in a database and for organization purposes. Think of a schema as a blueprint defining a database structure. Now, for tables and views that live within a database, those tables I want you to think of as organizing data in columns and rows that are being stored. They are not dynamic in nature, they are created and then they're referenced. Whereas with a view, it's a customizable presentation of a table's data. And so in that sense, that data is not currently stored in memory. It's more of a dynamic presentation of the data that lives within a table. And you can perform different types of transformations and calculations on the fly dynamically using views. Next, let's dive into what a table consists of. So the table is comprised of a few different things, including rows, which are individual records in a table, each line item being its own row. Columns, which are specific attributes defining data. So for example, you may have a date column, you may have an account number column, a name column. All of these are specific attributes that define the data. Next, you have different data types, and this is an important thing to note. The data type characterizes the nature of data in the columns. As mentioned earlier, if you have a date column, you would want that data type to be date. If you had a date time, you would want it to be date time. If you had a number, for example, it would be an integer. And if you had a string or a text somewhere in your table, you might want that to be a varchar or a char. And within a data table, it's a structure that stores data in a tabular form, allowing for efficient data management and retrieval. Next, I want to talk about the role of views. Now, you may be asking yourself, if I have a table, why would I need a virtual table or a view on top of that? Well, virtual tables generated by queries or views are important in a database for creating a query, essentially showing a subset of the data from one or more tables in different ways. That to say that you can join data from one table over to another. And so let's say, for example, you have a sales table and you also have a sales and team table. You could then join up your sales team with your sales and be able to see, for example, who is performing the best or the most sales in a given month. These are the types of use cases that you can go through by creating a view that you could not if you only had tables. Essentially, we are going to simplify complex queries, enhance data security, query the data for a specific perspective or a specific need. With that being said, we're going to jump into SQL. And SQL is essential for database communication. The different types of applications that exist for using SQL include data querying, updating, and managing data. SQL is a domain-specific language used in programming for managing and manipulating relational databases as well as non-relational databases. Learning SQL does not need to be difficult, especially when you have the basics covered. And the basics being select, from, where, insert, update, and delete. Select is essentially used for all of your different types of querying, and it's used to retrieve data from a database, typically in the form of referencing columns, as we've mentioned earlier. The from statement, which is a component within SQL that specifies the source, table, or view that you want to reference. Where clause. The where clause applies different types of conditions to the query that you're construing. The insert, update, and delete are used to modify data within a table. In the example that I mentioned earlier, say we wanted to return all of the employees from the employees table within the sales department, and we have an employees table. All we need to do is select the column name from the employees table where the department is equal to, quote, sales. This will return all of the employees from the sales department. Easy, right? Next, let's look at another example where we want to return all of the book titles from the books table that are within the fantasy genre and written by the author J.K. Rowling. So first we're going to be referencing, and I like to start actually with the from. It's important that you start with the from because you can bring in your specific object that you're referencing. Then when you bring in your from, a lot of the different tools that use SQL, as soon as you start typing out a column's name, will intelligently fill out the column. And in this case, we're bringing from the books table, selecting the title, and our where clause is genre equal to fantasy and author equal to J.K. Rowling. In this video, I don't want to cover too much syntax. I want to give some time to be able to practice and learn these ins and outs of this basic syntax very well before we continue on to the next video. However, I do want to touch on some market research on SQL usage. Now, SQL remains a fundamental tool in data-driven businesses, playing a crucial role across various industries, including finance, healthcare, and technology. SQL is and has been the most popular language for data work, even surpassing programming languages like Python and R in terms of usage. SQL is the top language used by data professionals, highlighting its essential role in data science and analytics. The demand for SQL skills is soaring as companies recognize the value of data analysis within their organization for gaining a competitive edge over their competitors. Some of the statistics include over 80% of companies rely on SQL for their data needs, and over 96% of Fortune Global 100 companies use Microsoft SQL Server, which, you guessed it, uses SQL. The different types of career opportunities that are available in the field of data include data analyst, database administrator, data scientist. All of these roles rely on this skill of knowing SQL and its importance and proficiency as a foundational skill for data and data science. SQL being that domain language used in programming for managing and manipulating relational databases is an essential skill that needs to be learned for anyone who is involved in data today. Next, what I want to do is have some extra practice, and this extra practice is on LeetCode. And if you're unfamiliar with LeetCode, it is a free website where you can test your skills in various different programming languages, including SQL. So I don't actually want to spoil the answer for you. You can solve the problem using all of the syntax we've learned today, including select, from, and where. And so in the next video, starting off, I'm going to show the answer to that question before we dive into the more intermediate content. But until then, thank you for joining me in this video. I hope you learned something, and I'll see you in the next one.